Okay, so welcome to part 3 of the fall semester midterm review. We'll continue where we left off. All right, let's flash back to our work on, okay, so we left off with number 59, where that'll go through those word problems there, and then we'll get to this next section, starting with number 61, solve each system by elimination, okay? So I might work a couple of problems here so you can see what is going on. I think I will work number 60. So look at number 61. Before you can solve number 61, you need to get this 10x over on the left side of the equal sign. So you need to subtract 10x from both sides, and you'll have negative 10x minus 2y equals 28. Okay, so that's how you'll solve. You'll need to solve that system. I think I'm going to need to work a few of these. So let me write this down while you're looking at it. We'll look at number 61. We'll do that real quick. Number 61, negative 4y plus 28 equals negative 8x. And then you're given negative 2y equals 28 plus 10x. It wants us to solve using elimination. So let's flash back to our work surface and figure this out. Okay, so number 61. Both of these equations here need to be kind of mixed up and unwrapped and fixed up before we can really work with them. Because here I've got negative 8x on the right, and that's not going to work. We need to move that over. We need to move this 28 over to the right here, move the negative 8x over to the left side. Then in the second equation, we need to move the 10x to the left side. So a little bit of microsurgery here before we can begin. Let's take negative 4y. Well, we'll do it this way. We need to transform these equations first. Okay, so I'll take the first one, negative 4y plus 28 equals negative 8x. Okay, so the first thing we need to do is add 8x to both sides. On the right, that will cancel, leaving 0. Okay, so be careful. You're going to have 0 on the right side here. So you now have 8x minus 4y plus 28 equals 0. Okay, so what do I need to do to get this into standard form, or the form that I need to solve using elimination? I need to move this 28 by subtracting 28 from both sides to the right side, minus 28 from both sides. Okay, so on the left side, the 28's cancel, leaving 8x minus 4y equals negative 28. Okay, and so we'll write that corrected equation up here, 8x minus 4y equals negative 28. We'll do the same thing for the second equation. Down here we've got negative 2y equals 28 plus 10x. Okay, so here I need to subtract 10x to get 10x over on the left. Okay, that cancels out on the right. Now I have negative 10x minus 2y equals 28. Okay, so now I need to put this up here. Negative 10x minus 2y equals positive 28. So that's the system that I can use to solve using elimination. So here we'll create a little space here. We'll kind of carve out a little space here where we can kind of work in a clean environment. So here we've got 8x minus 4y equals negative 28. And then we have negative 10x minus 2y equals 28. All right, it should be apparent now that we cannot just solve this by adding or subtracting, because nowhere will I be able to eliminate by stack adding or stack subtracting. We don't want to look here. This is not relevant. So first thing I need to do is change one of my equations such that when I multiply some number through the entire equation, it will have the same integer value on the top and the bottom. So looking at this lower equation here, put some parentheses around the lower equation, and I'm going to multiply something through the entire equation to make the numbers on the bottom, one of the numbers on the bottom match the number on the top equation. So that would actually be, I could do this one of two ways. I could multiply everything by -2 and solve using elimination by addition, because I would multiply -2 times -10x, -2 times -2y, -2 times 28. And when I multiplied -2 times -2y, I would have positive 4y, and I could add positive 4y to -4y and eliminate the y variable. I think that's what I want to do. I'll multiply by -2. So that's going to require me to multiply that -2 through the entire equation, just like that. Okay, so we'll do that real quick. I'm going to have -2 times -10x is positive 20x, and then -2 times -2y gives me positive 4y, which is what I wanted. Now -2 times 28 gives me -56. All right, so once again, we'll write our system here, 8x minus 4y equals -28. And then below it, our new equation, 20x plus 4y equals -56. All right, now if I use elimination by addition, when I add, that will eliminate the y variable. So we'll do that. We'll add 8 plus 20 is 28x equals -28 minus 56. So we're going to be bigger in a negative sense. So that's kind of like the way I do it without a calculator, is to just add 28 and 56 and then put a negative sign in front of it. So 8 plus 6 is 14. 2 plus 5 is 7, 8. So I should have -84. I'll double check on the calculator. -28 minus 56 gives me -84. Okay. So now I need to divide both sides by 28 to get the x by itself. On the left side, the 28's cancel, leaving x by itself equals -84 divided by 28. And negative 84 divided by 28 gives negative 3. Okay, so now that I know that x is negative 3, I can plug negative 3 in for x in one of my original equations. All right, so it looks like the top equation is kind of the easier one to deal with. So I'll say 8 times, open parentheses here for negative 3, minus 4 times y equals negative 28. So 8 times negative 3 is negative 24 minus 4y equals negative 28. Okay, so now I want to get that y by itself, so I'll add 24 to both sides. And that will get rid of that term. And now I have negative 4y equals negative 28 plus 24. So that gives me negative 4. Right? So negative 4y divided by negative 4 and negative 4 divided by negative 4 tells me that y, these cancel, y is equal to 1. So I think my x comma y here is negative 3 comma 1. But I can check that using my matrix editor. Once I got to this point where I had rewritten my equations correctly, I can plug these into my matrix editor. So if you were playing the matrix game, you would need to do this stuff here and get these equations like this. Then you could plug these into your matrix table as follows. All right, so what number goes here? 8. Here, negative 4. Here, negative 28. And then here, negative 10. Here, negative 2. And here, 28. Okay, so open up the calculator again and hit second matrix. See, I've still got this stored in here. If you didn't, you would need to create a 2x3 matrix under the edit menu. As it stands, I've already got a 2x3 matrix, so I can just replace my values that were already in there from some previous problem with these values. 8, enter, negative 4, enter, negative 28, enter, negative 10, enter, negative 2, enter, and 28, enter. Okay, then hit second, quit, then hit second matrix, tab over to math, and go down to B for reduced row echelon form, or RREF, and hit enter. Okay, so you've got RREF. Now hit second matrix again, and then enter on A to grab that table value from A, and enter one more time. And what we're given is 1, 0, negative 3, and 0, 1, 1. Okay, so in the same way that x and y are related diagonally, 1 and 1 are related, and that's how we know that negative 3 equals x and 1 equals y. So again, confirming what we did algebraically here, negative 3 and 1. And let's go back to our homework, looking at 61. I'm looking for negative 3 comma 1. And I see that I have that with answer choice B. Okay, so the solution to this system of linear equations, this is B. And this data right here, this is B. Okay, so that's number 61. Okay, Let's flip the page over. Let's move on to another number from the same section. Go. Number 62 is solved in a similar manner to number 61. Let's look at number 63. Okay, so let me show you number 63 and take a look at that while we write it out. Number 63 is going to be a challenging problem, I think, but it'll be fun because it's challenging. I have negative 5 over 2 y equals negative 7 plus 2x. And then I have x equals negative 2/3 minus 10/3 y. Okay, so that's my system. They want me to solve using elimination. All right, so in this situation, I still have to get these in standard form. I've got to rearrange the terms of both equations to get them in standard form. By this point, I hope you realize that when you're solving systems of equations, you're solving systems of equations in something that looks kind of like standard form. You have this, you have like an ax and a by and a c. The only difference is sometimes these are not whole numbers, but they kind of look like standard form equations. So let's rearrange terms first. For this first equation, we have negative 5 over 2y equals negative 7 plus 2x. All right, so let's play with this one. Okay, so first I want to get this x term over here, so I'll subtract 2x from both sides. Okay, that cancels out on the right, and I have negative 2x minus 5 over 2y equals negative 7. Alrighty. Okay, and then I have this second equation. Well, let me actually let me say something here. So let's just say that we wanted to turn this whole thing into correct standard form, if you wanted to, kind of pulling in from another part of the homework assignment, because this kind of it's just begging to be corrected. So I want all the numbers to be whole numbers. What can I multiply through to make all the numbers whole numbers and the leading coefficient positive? So I could multiply everything by negative 2. See, if I multiply everything by negative 2, then that would change all these values to, like I'd have here, if I distribute this negative 2 through every component there, I'll have 4x. And then these negative 2's cancel when I do this. Negative 2 times negative 5 over 2. I could cancel out negative 2 here and negative 2 on the bottom, and I'll have just plus 5y. Okay, and it equals negative 2 times negative 7, 14. So you could have converted that to standard form like that. So that's one of the equations. So then I'll do the second equation. X equals negative 2/3 minus 10 over 3 times y. Okay, so now we're going to move this y term, plus 10 over 3 y, plus 10 over 3 y. I'll put that on the left side. So now I have, remember I want the x term first. So I want to pull this x term down in front. X plus 10 over 3 times y equals negative 2 over 3. Okay, once again, this is just begging to be turned into a correct standard form. And for this one, I need to multiply everything by 3. Okay, that'll eliminate these denominators here. So I'm going to multiply each term by 3. So I have 3x. So I'm going to write this in black. I have 3x. And then here the 3's cancel. Plus 10y equals, and here the 3's cancel, negative 2. All right, so I have these two standard form equations now. I'll plug those in up here. This one turned into 4x plus 5y equals 14. And this down here turned into 3x plus 10y equals negative 2. You see how by converting to standard form, we've now made our life a lot easier. We're not having to work with fractions, and that's just always better. So here I'm going to need to multiply through on one of my equations by some number such that when I stack add or stack subtract, I'll have something that where one of the variables will be eliminated. And I hope we're starting to see patterns emerging here that if I multiply the entire top equation by negative 2, that will turn this into negative 10y. Then when I stack add, it'll be negative 10y and positive 10y. They'll eliminate each other, okay? Using elimination by addition. And we can kind of choose our own adventure here. We could have done elimination by subtraction, but addition, just for some reason I find it to be easier. So I'm going to create a work surface here. 4x plus 5y equals 14. I'll perform this little thing here where I'm going to multiply everything by negative 2. Okay, so negative 2, negative 2, and negative 2. So negative 2 times 4x is negative 8x. Negative 2 times 5y is negative 10y. And negative 2 times 14 is equals to negative 28. All right. So far so good. Now just put this guy right underneath him. 3x plus 10y equal to negative 2. And now we can solve the system using addition. Okay. See, these terms cancel using addition. So now I have negative 8x plus 3x, which gives me negative 5x. Okay, that y term is gone, equal to negative 28 minus 2. So that's negative 30. Right, so divide both sides by negative 5. And we have these canceling out. And x equals negative 30 divided by negative 5, or x equals 6. Okay, so now we can substitute x equals 6 for either of our equations. So we'll go up here, I don't know, we'll use the top one just because there's no negative numbers. I've got 4, open parentheses, 6 plus 5y equals 14. So I have here 24 plus 5y equals 14. Okay, so subtract 24 from both sides. And see, it cancels out on the left, leaving 5y. Now I need to take 14 and subtract 24 from it. And what that's kind of like saying is say 24 minus 14. Okay. No, rather, sorry. I'm taking, 24 minus 14 and it will end up being a negative number. So it's 24 minus 14, that's 14, 10. So I should have negative 10. 14 minus 24 should be equal to negative 10. We'll just confirm that. 14 minus 24, yep, is equal to negative 10. So then I'll divide both sides by 5. Okay, and now to cancel those out, and y equals negative 10 over 5, which is just negative 2. So I think that if we do x comma y, our system solves out to 6 comma negative 2. But we can check that. Back up here, once you had converted to standard form, or even if you had stopped and just had these ugly looking equation with lots of fractions, you can plug these values into your matrix editor and we can check. I really like these problems because they constantly make you think and kind of keep you on your toes. So at least it's never boring. All right, so our values here are 4, 5, and 14. And the values here are 3, 10, and negative 2. Okay, so back to the matrix editor, second matrix, over to edit. We're just going to replace our existing values with 4, enter 5, enter 14, enter 3, enter 10, enter negative 2, enter. Then I'll hit second quit, second matrix, over to math, down to RREF, and then second matrix, enter, enter. Okay, and what it gave me was 1, 0, 6, and 0, 1, negative 2, right? And so this is equal to x, and this is equal to y. So here's our confirmation again that we think we're right anyway. So what we're looking for here, that matches this, by the way, 6 comma negative 2, 6 comma negative 2. Let's see if we can find 6 comma negative 2 in our answer choices. So this is number 63. Transition back, number 63. 6 comma negative 2 is D. Okay, so that was answer choice D for number 63. Okay, there. All right, so one more from this section, and I think we'll be good. Let's look at number 64, okay? Number 64. Number 64 says, okay, number 64, negative 5x minus y equals negative 2. Negative 10x minus 6y equals negative 12. All right, so let's flash back to our workspace here. And this is where I want to bring in something we started with a long time ago, which is, well, let's just try to solve it using our existing methods. So if I'm going to solve this, let me use my, if I want to solve using elimination by addition, the first thing I have to do is multiply all the terms in the top equation by negative 6. Okay, so just like that. And we'll see why we do that here in a second. So negative 6 times negative 5x is 30x. Okay, and then I've got plus 6y equals, and then negative 6 times negative 2 gives me positive 12. And then below that, I'll just write this equation. Negative 10x minus 6y equals negative 12. All right, now let's solve it out using elimination by addition. The 6y's cancel out, and I have 30 plus negative 10x, which is the same thing as 30x minus 10x, which gives me 20x equals 12 plus negative 12 equals 0. Okay, so here, if I divide both sides by 20, the 20's cancel on the left, and x is equal to 0 divided by 20, which is 0. All right, that's not, so far we're not in hot water yet. So let's plug that 0 back in to one of our original equations. We'll take the top one, negative 5, open parentheses, times 0 minus y equals negative 2. Okay, so negative 5 times 0 just is 0, so I have negative y equals negative 2. Okay, so here I can just change these signs. Positive y equals positive 2. If negative y equals negative 2, then positive y equals positive 2. So my equation is 0, comma 2 for x, comma y. If I wanted to solve this using the matrix editor, I would create this little table. And I would have here negative 5, negative 1, negative 2, negative 10, negative 6, and negative 12. Okay. Go back to our second matrix, over to edit, and just change these values. Negative 5, enter negative 1, enter negative 2, enter negative 10, enter negative 6, enter negative 12, enter. Second quit, second matrix, over to math, down to B for reduced row echelon form. Whoops, I made a little mistake. So now the second matrix, and then enter, enter. Okay, so it gives me 1, 0, 0, and 0, 1, 2. Okay, so in that case, 0 equals x, and 2 equals y. Okay, so we solve this system again using elimination by addition. So again, we're looking for 0, comma 2. So see if our answer choices show that. And for number 64, 0, comma 2 is A. So I'm going to go with A for number 64. Okay, A for number 64. Now we are going to move on to substitution. Okay, so let's go here. We solve, so you guys will need to solve 62 and 65. Number 66. Okay, let's do number 66. So this one they're wanting us to solve using substitution as opposed to elimination. So everybody seems to like elimination more than substitution, but you still need it sometimes, like right now. So we're going to use substitution for number 66, and the equations that we're given are negative 2x minus 6y equals 0, okay, and 5x minus 8y equals 23. Okay, so let me flash back to our work surface here. I'm down here. Now I'm looking at this and trying to remember, what do I do for substitution again? Well, what you do is you solve for one of the variables, like manipulate one of the equations to get one of the variables by itself on the left, and then stick that in to the other equation. So it's better just to show it. Let's take the top equation and solve for y. So I've got negative 2x minus 6y equals 0. Okay? So I'll add 2x to both sides. And that cancels out on the left, and I have negative 6y equals 2x. Divide both sides by negative 6. And you have, they cancel out on the left, and you have y equals 2x over 6, which is the same thing as saying y equals negative 1/3 x. All right, so here's the key thing. Now we have y equals negative 1/3 x. We can substitute that into our second equation here. Wherever we see a y, we're going to write negative 1/3 x. Okay, so here we're going to substitute. We're going to substitute negative 1/3 x for y, right, in the second equation. So I have 5x minus 8, open parentheses, and now instead of writing y, I'll write negative 1/3 x, close parentheses, equals 23. Okay, so since we're not trying to graph these equations, we don't have to set both of them equal to y and then graph them and find the intersection point. We're going to find the intersection point organically, or kind of implicitly. So now we're going to solve this out and find x by itself. So let's first figure this out. 5x. Now we have the negative 8 times negative 1/3 gives me positive 8 over 3x equals 23. Okay, so now subtract, I'm trying to solve for x by itself. So I have to think about this for a second. These are both x variables, so I need to combine them, but I can't combine them until I have a common denominator. So what I need to do is multiply 5x times 3 over 3. And that will give me a common denominator with 8/3 x. So that's 3 times 5x is 15 over 3x plus 8 over 3x equals 23. So what is 15 plus 8? It is 23. So I have 23 over 3x equals 23. All right, now how do I get x by itself? Well, I can multiply by the reciprocal, 3 over 23 times 23 over 3. And then on the other side, multiply by 3 over 23. Okay, so let's see what happens. On the left side, the 3's cancel and the 23's cancel, leaving x by itself. And on the right side, the 23's cancel, leaving 3 by itself. So x equals 3. Go back and watch that again if you need to see how I got that. And now what I'm going to do, since I've got x equals 3, I'm going to plug back into one of my original equations. It doesn't matter which. Everywhere I see an x, I'm going to write in a 3. So we'll take that first equation. See if I can do this. I'm running out of space. So back into that first equation, I've got negative 2, open parentheses, 3, close parentheses, minus 6y equals 0. All right. So negative 2 times 3 is negative 6 minus 6y equals 0. Add 6 to both sides. Add 6 to both sides here. They cancel on the left, so I have negative 6y equals 6. To solve for y, divide both sides by negative 6. They cancel on the left, leaving y by itself. Y equals 6 divided by negative 6, or negative 1. All right, so what it looks like is that the coordinates of my solution are x comma y, 3 comma negative 1. Right? If I wanted to use the matrix calculator to do this, I could. You wouldn't be solving by substitution, but if this is what you need, by all means. Here, we'll just plug in -2, -6, and 0, and then 5, -8, and 23. Okay? So here we go. Back to the matrix editor. Again, I'm sorry about the brightness issue there. Whatever. Second matrix, go over to Edit, Enter, and now we have -2, enter, -6, enter, 0, enter, 5, enter, -8, enter, 23, enter. Second quit, second matrix, math, down to reduced row echelon form, enter once, second matrix, enter, enter. And what we get from this is 1, 0, 3, 0, 1, -1. Okay, so 3 equals x and -1 equals y. Do we have an answer choice that gives me 3 comma -1? Well, let's go check. So this is number 66. 3 comma -1 is given in answer choice C. So number 66 is C. All right, so I think you can solve the rest of those. Now we're graphing linear inequalities, okay? So if you need a new piece of paper here. Number 70, we are given 3x plus 4y greater than -20. All right, so we'll graph that. Here we go. We got to remember all of our rules here for graphing inequalities now. So it's a lot like graphing any equation, but we have to be careful. This is given to us in standard form of inequality, ax plus by something c. Okay, this is an inequality symbol this time. So here's what I want you to do. Many people want me to tell them how to stick this into a calculator, and you can't do it like this. You have to adjust this equation so that we need to get this y by itself. So kind of like y equals, but this is going to be y with a inequality symbol. So you're going to subtract 3x from both sides. Remember, it's okay. The inequality symbol will stay the same unless you multiply or divide by a negative number. All right? So over here, the x's cancel, leaving 4y greater than, and then we have -20 and -3x. So put the -3x up front and the -20 because those two things don't mix. Remember, these are unlike terms. Don't try to blend them together in any way. Just write it out like that. Okay, now divide every term in the inequality by 4. So since this is not a negative number, it won't affect the sign. I'm going to divide everything by 4. On the left, you get y by itself. Y is greater than -3/4 x minus 5, because 20 divided by 4 is 5. So this is what you're going to graph. Okay? Now let's remember our rules for graphing inequalities. This symbol, greater than symbol, okay, means that I'm going to have a dotted line and everything is going to be graphed above the line, like that. Okay, so let's start by creating a graph. And I have here, this is the fun part because you get to graph. Okay, this is the y-axis and the x-axis, and I have here 0, -1, -2, -3, -4, -5. All right, so we have to go to our y-intercept of -5 right here. So this is 0, -5. And then I'm going to use the slope, which is -3/4 x. I see I'm going to run out of space, whatever. I'll use the slope of -3/4 x to graph in some points on this line. So here I could go down 3 over 4. Okay, I'm going to have to extend this out. So this would be -6, -7, -8, -9. All right, let's go. Let's starting at the y-intercept. Let's graph it in a different color. Let's go down 3, down 1, down 2, down 3, and then over to the right 4. Right? 1, 2, 3, 4. Okay, so there's my point. And this is going to be, let's fill in 1, 2, 3, 4. This is going to be point, this right here is going to be point 4, -8 that I'm just plotted there. Now I'll graph in my line. Remember, I'm going to put a dashed line. A dashed line, not a solid line. We need to say greater than or equal to in order for me to get that solid line. So there's my dashed line, and I'm going to shade above the line. All right, so we'll shade above the line, and that'll look like that. Okay, it'll kind of look like that when I shade that all in. And that is the inequality. Y is greater than -3/4 x minus 5. And you say, well, how do I use that inequality thing on the calculator? Okay, sure. All right, so you need to get this. Once you get this, you can kind of rock and roll. Let's go to the calculator, open it up, and you have to look really closely because this is dark. But what we do is we hit on apps, and if your calculator is in test mode, this won't work, but if it's not, welcome to inequals. For people using the orange and white and black calculators, the TI-84 pluses, I think it's going to be down below the line, but for this version, just find inequals. So for me it's 7, I think for you it's 0. So let's start the inequality graphing utility, and this thing comes up. And then for all of you, follow the instructions on the bottom of your calculator. For me, I have to change this symbol. Okay, I've got to change my symbol here to greater than. Okay, and then now I have y is greater than, and I need to hit alpha y equals, enter, -3 over 4 x minus 5, and then graph that. And it's really hard to see. But what's being graphed, let me see if I can change the color. Maybe that'll help. You see how it's graphing just like the way the graph is on the paper? All right, so I'm pretty sure that we're right there. So let's go back into our, we're looking for a y-intercept at -5 with a dashed line shaded above. So let's go back to our answer choices. Y-intercept at -5 shaded above. For number 70, right? So downward sloping line, y-intercept between -4 and -6, shaded above. I think it's B. I think it's B. I think this is the answer choice B. Okay. So I think it's answer choice B for number 70. And that's good enough there. You guys remember how to graph inequalities. There's an entire linear inequalities graphing test solutions tutorial in under the video history. If you click on Athenian Stranger videos, scroll down, you'll find linear inequalities test solutions. There's 2.5 hours of this. So if you guys need extra help with that, go look at that other tutorial. But that's how you solve number 70. Let's see what's coming up next. Right? So you'll solve number 71, 72, 73. Now we are into this new series of questions, starting with number 74. And these are work and speed questions. These are fun. More word problems. Everyone's favorite. Okay, let's read number 74 together. Mark can mop a warehouse in 9 hours. Abazra can mop the same warehouse in 6 hours. If they work together, how long would it take them? Okay, so I'm going to be writing some things down while you read that again. Mark takes 9 hours, and Abazra takes 6 hours. Okay, so if they work together, how long would it take them? All right, so let's go to, it says here in the hints, set up fractional per hour for each participant. All right, let me show you what I'm talking about here. Back to our work surface for number 74. And I just wrote down Mark 9, Abazra 6. So here's how you solve questions like this. You create fractions. So like 1 over 9, and they're going to work together, right? Plus 1 over 6. And that's actually what we want to find. So 1 over 9 and 1 over 6. Okay? So we have to find a common denominator. So I'll multiply this one by 6 over 6 and this one by 9 over 9. I didn't need to do that. Wait, there's an easier one. They share a common multiple of 2. So, no, yep. If I multiply, if I multiply 1 over 9 by 2 over 2, and I multiply 1 over 6 by 3 over 3, it's okay to do this because 2 over 2 is 1, 3 over 3 is 1. So that's 2/18 plus 3/18. And you get 5/18. Okay, now to solve this, you divide 18 by 5 to find out how much time it would take them to clean the warehouse working together. All right, so 5 goes into 18 3 times. That's 15. Left over 3. Point, bring down a 0. 5 goes into 36 times. So what this is saying is working together, Mark and Abazra can clean the warehouse in 3.6 hours. Okay, solve that. Hopefully that's one of our answer choices. Let's flip back and take a look at number 74. Yep, C is 3.6. So number 74, answer choice is C, 3.6. And if you want to, pause that and go back and look, you're going to do the same thing for the next problem. Okay, so that was easier than it looked, I hope. Okay, let's just look at 75. It takes Dan 10 hours to oil the lanes. Anjali can oil the same lanes in 5 hours, just like 1/10 plus 1/5, which is 2/10. So you have 3/10. 10 divided by 3 gives you 3.333. I think it's B. I don't know, I just did it in my head. But just set it up just like you did 74, and it should work. All right. Now, okay, 76 is the same way. Now, numbers 77, 78, and 79 are speed questions. Okay, so let's take a look at those. Let's take a look at number 77. Trevin left home and drove toward the desert at an average speed of 38 miles per hour. Okay, so while you're reading that, I'm going to draw something. So it's to say Trevin toward the desert at 38 mph. And then sometime later, Jessica drove in the opposite direction at 37 mph. After Trevin had driven for 5 hours, so after 5 hours, they were 301 miles apart. How long did Jessica drive? Okay, so, let's go back to our work surface and I'll show you how to solve questions like this. It's not that hard. Okay, the best thing to do, in my opinion, is make a little picture. Okay, so here's the starting point. Here's the starting point. Trevin, we'll do in red, he drove toward the desert at 38 miles per hour. So this is Trevin at 38 miles per hour. And then Jessica, she left from the same position. Okay, she left from the same position and she drove off in this direction. Okay, Jessica at 37 miles per hour. And the question is, how long did Jessica drive if after 5 hours they were 301 miles apart? Now see, here's how you set this up. How fast is Trevin driving? He's driving 38 miles per hour. So you take 38 and you figure out how far did this guy drive in 5 hours. Multiply 38 by 5, and 8 times 5 is 40. 3 times 5 is 15. So we know that Trevin drove 190 miles in 5 hours. So we say Trevin 190 miles in 5 hours. All right. So we were given 301 miles apart. So now we can find out the distance that Jessica drove. So say Jessica drove then 301 minus the distance that Trevin drove, 190, minus 190. Jessica drove 301 minus 190. I'm going to cheat and use a calculator. 301 minus 190 gives me 111. So Jessica drove 111 miles. Let me just make sure. 38 times 5. Yep. So if Jessica is driving at an average speed of 37 miles per hour, how long has she been driving if she's driving 111 miles? So what you do is divide 111 by 37. So this is 111 miles by 37 miles per hour. And what we're going to get are hours because the m's will cancel. So now we got 111 divided by 37 gives me 3 hours. That's how long Jessica has been driving. Okay, so this is the answer that we came up with. We'll check our answer choices and see if we have 3 hours as an answer choice. Okay, 77, yep, 77, that's answer choice A, 3 hours. So number 78 and 79 are solved in the same kind of way. Okay, so we'll move down to number 80 and solve a proportion. All right, I think I can fit that on the same page. Actually, maybe it'll be off the page. Be like this. Can solve number 80. 80 is 3n minus 6 over 11 equals n minus 6 over 6. Okay, so let me flash back to work surface here. This one's going to look a little weird. It's falling off the page. So here's number 80. So we set up the proportion, and what we're going to do is, many of you call this butterfly math. That means we're going to multiply these together and these together, see what we get. All right, so here's how you set this up. Put the 6 here, open paren, 3n minus 6, close paren, equals 11, open paren, n minus 6, close paren. Okay, so now we're going to distribute that 6 here, and we're going to distribute the 11 here, and then we're going to solve for n. So 6 times 3n is 18n, and 6 times negative 6 is negative 36, okay, equals 11n, and then 11 times negative 6 is minus 66. So now we're just going to kind of solve for n, all right? So to solve for n, let me add 36 to both sides to get rid of it on the left. 66 plus 36, and on the left side they cancel, leaving 18n by itself. Okay, equals 11n, and then negative 66 plus 36. I'm cheating again. That gives me minus negative 30. Okay, so I want to get n by itself. This time I just subtract 11n. Many of you will be like in a habit at this point, and you'll try to divide, but just subtract 11n from both sides. They cancel on the right, and on the left, I've got 18 minus 11. Okay, so what is that, 7? 7, is that right, 18? Yep, just going crazy. 7n equals negative 30. All right, so divide both sides by 7. And they cancel on the left. N equals negative 30 over 7. How are the problems? Yep. So we'll just leave it that way. They don't want us to turn it into a decimal. Okay, negative 30 over 7. Okay, so if we go back to our answer choices and look at number 80, sure enough, D gives negative 30 over 7. But let's say you'd been using the calculator and you had actually, gone out with the decimal there, and you did negative 30 divided by 7, you'd come up with this crazy looking decimal there. I think if you hit math frac and then enter, it'll turn it into a fraction for you. Okay, so that's how you solve number 80. And let's take a look. I think that's probably good enough to solve all those proportion problems. Yep, you solve them all kind of the same way. All right, let's move down to 85 and find the distance between 2 points. Okay. So number 85, okay, even if you can't recall the distance formula, you can do this. So 85, you're given 2 points. You're given -5 and you're given 3. You're also given 4 and -1. All right, so let's use the distance formula here. Back here. Okay, so here's what I want to do. I actually want to draw a graph and plot these points on the graph. So let me draw a little quick graph here. And I'm going to need to go down to -5 and up to +4. And draw a graph like this. Okay. So here's the y-axis and the x-axis. Here's 0, and then 1, 2, 3, 4, 5, -1, -2, -3, -4, -5, 1, 2, 3, 4, 5. Okay, so let's plot these two coordinates that we're given. We're given -5, 3. So go down to -5 over to 3. And here's that coordinate plotted. Wow, I just made a huge mistake. Sorry. Starting to get a little bit tired. So x, y. Sorry. This is x, this is y. This is x, and this is y. And so that's x1, y1, x2, y2. All right. Let's try that again. Actually, I'm going to need to extend this out because I just read it wrong. Okay, so again, human being. All right. Just get rid of that. So I actually need to go -1, -2, -3, -4, -5. All right. So now looking at those points correctly, let's go on the x-axis to -5 and then up to 3. Let's plot that point there, right? So big mistake on my part. Sorry about that. So this is -5, 3. And then I'm going to plot 4, -1. So I go over 4 on the x-axis and down 1 right there. So there is 4, -1. And what I want to do is I want to find this distance. Okay, I want to know what is this distance here. Okay, what is that distance? Well, we can actually use the Pythagorean equation. So we can actually I'm going to form a fake right triangle with dashed lines here and show you how to do this. So take the points and connect them to make a right triangle. See, this is a right triangle here. And we're going to find the distance. Here's this new point here. Okay, what is the distance? Just count the boxes. 1, 2, 3, 4. So this here is 4, and we'll arbitrarily call that A. And how many boxes in between these 2 points? Here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there are 9 boxes here, so 9, and this is going to be equal to B. All right, so now we want to know what C is. And the way we find it is by saying, well, look, Pythagorean equation, a squared plus b squared equals c squared. So if I wanted to find c, I could just plug in 4 squared plus 9 squared equals c squared, and I'd have 16 plus 81 equals c squared. 16 plus 81 is 97. 97 equals c squared. So c equals the square root of 97. And so c equals the square root of 97, which is 9.85. Is that right? So c equals 9.85 is the approximate value there for c. I kind of just want to check and see if, so this is 9.85-ish, so approximately. So let's go back to our homework and see. Yeah, on 85 we did have one that was 9.8, so that's probably the correct answer. So I'll go with A for number 85. And that's how you solve those distance equations. It's not too bad. Okay, so now we're going to solve each equation for the indicated variable. Okay, and I will solve number 88. We are given C over A equals R minus D. And it says solve for A. All right. Let's go back to our, so in here we're not actually going to calculate some number. We're just going to solve for some letter. All right. So here, it might be helpful to think about this. R minus D can be written as R minus D over 1, and then you have kind of a proportion, right? So you could write little parentheses there. Then when you do your butterfly math, watch what you get here. You get A, open paren, R minus D, close paren, equals C times 1 is just C, so C. Okay, so now we have to think about this. We can actually divide out whole parenthetical expressions. This is something that we need to practice more, I think. We're going to divide out R minus D from both sides. R minus D. Now they cancel on the left, leaving A by itself. A equals C over R minus D. Now, is that an answer choice? Said solve for A. Let's go back to our homework. Okay, so 88, A equals C over R minus D. A equals C over R minus D is the answer for B. It's the B answer choice. So select B for 88. All right, so 89 and 90 are solved the same way. Just use that. Remember to put a n minus p over 1 and then solve it like a proportion. Number 90, I'll give some assistance on number 90 just to kind of finish it off so you get the last one taken care of. So the last question, wow, xc equals d over r, and it says solve for x. Okay, fair enough. Okay, so we're going to do number 90 here. So it's kind of the same thing. This can be done in one of two ways, the easy way or the hard way. So really all I need to do is divide out the c on both sides. But this is going to be, so I'm going to divide by c. This is going to get confusing real fast, right? So let's have to think about this again. Let's rewrite it. xc equals d over r. So here's what I'm actually saying I want to do. When I divide by c, what I'm actually doing is I'm multiplying this side by 1 over c. Okay? So if I want to divide d over r by c, I'm going to multiply this side also by 1 over c. All right, now when I do that, on the left, I have xc over c, and these c's cancel out, leaving x by itself. So x equals d over, and then r times c, rc. So x equals d over rc is the solution. The trick here was that 1 over c thing. Otherwise, you have d divided by r divided by c, and it's confusing. Just remember that when you're dividing out, you're really multiplying by the reciprocal, and you'll be okay. So let's go back to our answer choices for number 90. And we're solving for x. X equals d over r times c. Here's x equals d over c times r, same thing. So it's answer choice D. All right, so that was, as promised, one problem from each section of the math homework. And I think I'll probably make a copy of the math homework available in the descriptions of each of these videos as like a link to a Google Drive file or something, so you can look at this. If you've been following along, you have finished 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 questions. So there's only 90 questions, guys. So we finished 25 of the 90 questions in this tutorial. Now we finished 25 divided by 90 times 100. So we finished 27.777% of this entire assignment has been handed to you here in this 3-part tutorial series. So I hope that was helpful. Please leave a like and subscribe. Hit that bell for notifications of new videos, and have a pleasant day.